So, in my opinion, this is like an expert question. This is one of the more difficult ones in my opinion, to get full credit on. And I'll probably be asking Ms. Lamb for her help on anything I might have missed on scoring guideline. It's important because this is actually, like I said, this is a difficult question. Not so much to actually solve, but to get all the points. So, a Big Town Fisheries recently stocked a new lake in a city park with 2,000 fish of various sizes. The distribution of the lengths of this fish are normally approximately normal. Yay, those are good words. Big Town Fisheries claimed that the mean length of the fish is 8 inches. If the claim is true, which of the following would be more likely? A random sample of 15 fish having a mean length that is greater than 10, or a random sample of 50 fish having a mean length that is greater than 10 inches. Justify your answer. So a random sample of 15 fish is more likely to have a mean length greater than 10 inches than that of a random sample of 50 fish. I answered the question. Why? So then, and that's the justify your answer part. The distribution of sample means standard deviation is the population divided by the square root of n. And what that means, as the sample size increases, the variation decreases. And we specifically have to address variation in this problem to receive credit. As a consequence, a sample of 50 would result in a distribution that is less spread out than a sample of 15. The result is that a value which is 2 away from the true mean, in other words, 10 was 2 away from 8, is less likely with a sample of 50 because that sample has less area in the tails than a sample of 15. We'll skip the equations for just a moment. They really would have liked to have seen a graph, whether you had 2 separate or stacked them on top. But I basically said, okay, we have a mean at 8. We have a sample of 50. We also have a mean of 8 and a sample of 15. Well, we can see that with the sample of 15, we have larger area in the tails. With the sample of 50, we have smaller area in the tails. The graph was not required, but they did want to see, they liked seeing it. Now, that wasn't the only way to get full credit. And then another way would have been to come back and go, you know what, run a test and show us. But I look back up here and I don't see a standard deviation given. There's not one given. Now, they did give one in part B, and you could either use that or you could have made up a standard deviation. I went ahead and used their standard deviation in part B because it's like, you know what? A lot of times students will read further down and go, hey, they give me more information, I'll use that. Well, if I had used that, I actually get probabilities of 0 for both of them, for both the 15 and the 50. So I'd have to compare my z-scores. And because this z-score is so much larger, I'd actually have, it's less likely. So I could have approached it this way and they would have given me credit for this, but what they really were looking for was an explanation based on variation, and they wanted to see the graph if possible, although it was not required. Ms. Lamb, am I leaving anything out of that one? Because I feel like I probably am.
No, that's basically what they said, so it's good.
Okay. Awesome, thank you. Suppose the standard deviation of the sampling distribution of the sample mean for random samples of size 50 is 0.3. I want to be really careful with this, and this is why I highlighted it. The standard deviation, not for the population, not for a sample of 50 fish, but for random samples of size 50. So that is 0.3, and we'll come back and address that a little further in just a moment. If the mean length of the fish is 8 inches, use the normal distribution to compute the probability that a random sample of 50 fish will have a mean length less than 7.5 inches. So X bar, the average weight is 50. The standard deviation of X bar is 0.3. So what they're saying is for samples of size 50, they have a 0.3 standard deviation, all right? So in this case, my initial desire is to use this formula. However, They're telling me how many samples of size 50 did I have? I only had one sample of size 50, and they tell me the standard deviation for samples of size 50 is 0.3. So I'm dividing by the square root of 0.3, not dividing by 0.3 divided by the square root of 50. So some of you are probably a little freaked out because you divided by the square root of 50, because that's what you're inclined to do. I totally understand that. The reason is, and if you miss this distinction, it's not the end of the world. If you miss this distinction, it's not the end of the world. They're saying they're saying samples of size 50 have this standard deviation. All right? They're not saying the population has a standard deviation of 0.3, and then you divide by the square root of 50 for that. Okay? Now, had you done this, had you divided by the square root of n, had you divided by the square root of n, you would have gotten partial credit. So it's not the end of the world. It would not have been the end of the world. You would have still gotten partial credit. So I'm going to go ahead and do this. I'm going to do this as a stat test, z-test, and we actually have a mean of 8, a standard deviation of 0.3, x is 7.5, and we have one sample of size 50, and we want to know the probability that we're less than that. So I get a negative 1.667, and the probability of that occurring is 0.048. All right? Then we write it up in context. Last question. Suppose the distribution of fish in this lake was non-normal. So in other words, they told us it was normal above, but now we're switching to non-normal. But we have the same mean standard deviation. Would it be appropriate to use the normal distribution to compute the probability in part B? Justify your answer. Well, we're talking about the distribution of sample means. And we know the distribution of sample means becomes normal for sample size 50 or for 30 or greater. So we just basically applied the central limit theorem. All right? So it's appropriate. So to answer the question, it is appropriate. Why? The central limit theorem applies because our sample size is reasonably large. Okay.